Hello everyone, and this is our last chapter we're going to review. So then we also have chapter 7, but as we all know by now, hopefully that is not going to be on your AP test. But we will get into later if we want, when we will still learn it, for those of you that are interested. So this chapter was differential equations, which I don't know what's going to be on your three FRQs for your AP test, but I would guess differential equations will definitely be on there. It might not be one where you have to actually solve it and separate it, and we'll talk about the difference when I get into the FRQ videos. But in this chapter, we did focus on how to solve differential equations by separating them. What do I mean by solve them is go back to the original. And we also talked about those growth and decay models and what that means. And then we also tied back in slope fields, so we will review slope fields at the end of the video. So let's just go ahead and get started. So it says find the solution y equals f of x for the differential equation. That just means find the original given the derivative, right? So how do we start these off is you first collect your x's on the right side and your y's on the left side. So your first step should always be multiply by dx to move it over. So then we have dy equals 2x over y dx. So then we need to move any y's over here, but we can only move it, remember, by multiplying or dividing. Never, ever, ever move a y over by adding or subtracting, or else it's not separable and you can't integrate it. But in this case, we know we would multiply by y since we're dividing by y. So we're multiplying by y over here. So then I'm going to rewrite my equation as y times dy equals 2x times dx. So now that we collected our y's on the left, our x's on the right, we're ready to integrate each side. So now we're integrating y with respect to y. So how do we integrate? We add 1 to the exponent and divide the coefficient. So that would become 1/2 y squared equals this side. That's a 1, add 1 is 2, divide the coefficient, that just becomes x squared. And on the x side is where you put your plus c. Do not put it on the y side, just only on the x side. You only need 1 plus c. Okay, and so then from there, if you had an initial condition, if you were going to get a particular solution, I would suggest plugging it in as soon as you solve for y. As soon as you integrate both sides and put plus c. Most of the time it's going to be easiest if you plug in your initial. You don't have to solve for y before you solve for c. We're going to make a note of that, but let's go ahead and finish this problem. So they do want you on these problems at the end. Your last step is get y alone, because it says find the solution y equals. So I'm going to come up here, and how would I get y alone? The first thing I would do is multiply by 2. So then I need to multiply this side by 2, and so this becomes y squared equals 2x squared. And then remember, when you technically we are distributing, but when you multiply c by a number, it's still just an unknown number, so we can keep that c. Which that is where you get in some issues if you try to solve your c later. It gets kind of messy. And so then we square root, right? So you got to square root this whole side. So then we're left with y. Now don't forget, if you have to square root to get y alone, technically it is always plus or minus that square root. And then we will talk about in one of the free responses in this packet is based on if they don't give you an initial condition, this would be your answer. If they gave you an initial condition, you would see if your y is positive, then it's the positive square root. If your y is negative, then it would be the negative square root, and you'd be able to pick which one out of those. Like, if that doesn't make sense, just wait until you try it for your response and watch the video. So I want to make a note before we do this one. I'm going to say, if I could write if given initial condition, or initial, which why do they give you initial condition to solve for c? I'm going to say plug in before solving for y. Plug in before solving for y, but it has to be after you integrate each side. So I'll say before solving for y and after integrating, because you shouldn't have a c to solve for until after you integrate. Integrating is probably better English, and after integrating. Now, I will say the exception is if when you integrate y and it's inside a natural log, then it might be easier to solve for y first. So I'm going to say unless y is inside ln. Okay, if y ends up being inside a natural log, I would get it outside the natural log first. But any other case, I would solve for my c before my y. I don't know if that made sense, but maybe as we do questions it will. So on this one, we need to first move our dx over, which you don't have to show the actual multiplication, but you do on these type of problems. You need to show every step because they want to see the separation. So we have times dx. Now we need to move over this e to the y. So that's being multiplied right now, so we're going to divide it by e to the y. So then we got to divide this side by e to the y. So I'm going to write this as 1 over e to the y dy. And these crossed off, so it's just 3x squared minus 6x dx. So we're ready to integrate. So how do we integrate this side? So we look at that and we think, okay, do we need u substitution? So what could I do for u substitution? I could set the bottom equal to u, but if you do that, I'm not going to put it on the actual thing because it's going to be wrong, but I just want to kind of go with maybe different thought processes. So let's say you pick u to be e to the y because it's on the denominator, then du would still be e to the y. And you don't have an extra e to the y. You can't box this e to the y because that's u. So that's just, you're just going to get stuck if you do that. Because that would be dy. And so it just doesn't make sense. We don't have an extra e to the y to box because this was your u. So we need to try something else. So what could you try if you have one term on the denominator? Is you bring it to the top using your exponent rule. So we're not going to integrate yet, but we are going to bring this e to the y term to the top by making it exponent negative. And you can do that even though it's a y and not a number. That rule still applies. And then I'll just go ahead and rewrite this one so I stay on the same page. That's ready to integrate over here. So now let's see, how am I going to integrate this side now? I'll still need u substitution because that's not just y anymore in the exponent. That is negative y. So that negative is going to make a very small difference. So technically you need to make u equal to the exponent. So then what does that make du? Well, what's the derivative? Oops, not dy. du. The derivative of negative y is just a negative 1 times dy. So if you notice, we have this dy, we have this dy, but we don't have that negative. So I need to move over the negative and make this negative 1 du equals dy. So now I can rewrite my integral in terms of u, correct? Because it's going to be the integral of e to the negative y, which was my u, and then my u's and y, they're looking too similar. That's a u right there. And then my dy equals negative 1 du. So what can I do with that negative 1? It's a coefficient. So I can bring it to the very front of my integral. And now I just have the integral of e to the u, you can walk by, which we know is e to the u. So, and you just keep your coefficient, so that'd be negative e to the u. So that is our left side. Now we got to go integrate our, oh, well, why don't we go ahead and replace our u also. So that's going to be negative e to the, u is representing negative y. So notice it's very similar, but if you didn't use u substitution, you would be missing this front negative. So that was my y side. So I'm going to come over here and rewrite that. So that's my integrated y side. Now that's going to equal, integrate my x side, add 1, divide the coefficient, which that just become x cubed, add 1, divide the coefficient, that'd be minus 3x squared plus c. So this is my integrated. So at this point is where you can, this one it gives you your initial condition, your x and your y. So you can go ahead and plug it in. Now you don't have to solve for y because y isn't inside the natural log, it's in an exponent. So it's probably going to be easier if we plug it in now. You don't technically have to. You could solve for y first, but let's see if this works out easier. So we have negative e to the negative 0 equals 1 cubed minus 3 times 1 squared plus c. So we know negative 0 is just 0, and anything to the power of 0 is 1, and then it has a negative coefficient, equals 1 minus 3 plus c. So this would be negative 1 equals negative 2 plus c. Add 2 to the other side, and that makes 1 equal to c. So you rewrite your general solution with your c value. So this would become negative e to the negative y equals x cubed minus 3x squared, and then because that's positive 1 plus 1. So we are not done. Your last step is now you solve it for y. So don't forget that last step because that is a point on your free response. So how do we solve this for y if y is in the exponent? First thing you got to do is you move over the coefficient. So if this is a negative 1, I have to divide, use a different color, by that negative 1, which means you divide this whole side by negative 1. And so this becomes e to the negative y. Now this would just change all the signs, right? Negative x cubed plus 3x squared, and then that becomes minus 1. Now that that's a number and not c, you actually do your algebra with it. That's why it's kind of easier to find a number first, because when you leave it c, just weird stuff can happen. And now how do we get this negative y out of an exponent? And we talked about this at the beginning of the chapter 5 review, is if it's in the exponent for e, then you're going to take natural log of each side. Because natural log of e cancels, and you're left with just negative y equals the natural log of negative x cubed plus 3x squared minus 1. And then you can divide by the negative, right? Because you have another negative, so divide by negative 1 again, which what happens here is this just becomes y, and when you divide this by negative 1, it just makes the whole natural log negative. It doesn't, you don't touch the stuff on the inside. And that should be your final answer. So if you did that problem, but you solved for y first and then your c, I think it would be messier than that. And your answer might look different. It's not necessarily wrong, but it's going to look different. Okay, so then we talked about this format. This is a special thing. How do you put this in words is the derivative, what's another word for derivative? The rate of change is proportional to the variable y. Proportional just means you multiply it by some constant and they equal. So if we solve this one, you should know just from chapter 6 what the original is that goes with that by memory, but if you don't, you would solve it by hand, right? So you would multiply by the dx, so you'd have dy equals ky dx. Now my advice is only divide by the y. Leave the k over here. So if we divide by the y, then I would write this 1 over y dy. I always like to put my dy dx in the back because it fits the format we're used to. X dx And now we can integrate. So what's the integral of 1 over y? You got to have that one memorized. That's a special one. That's natural log of y. If you move that y to the top and you add 1, you're going to get 0, and that's your red flag that it's supposed to be natural log. What's the integral of k? Because it's x is our variable. K is just a number. It's an unknown number. So if that was a 2, what's the integral of 2? 2x. So this would be kx, not kc, kx plus c. So in this problem, if it gave us an initial condition, we wouldn't plug in our x and y yet to solve for c because y is inside of natural log. So we want to get the y outside of the natural log first. So how do you get y outside of natural log? Is you raise it to the base e. Raise this side to the base e. So that becomes e and natural log cancels, so you're left with just y, the inside. And this becomes e to the power of kx plus c. But then remember, you don't have to show anything. You can go straight from this, and you can go back and look at your notes if you forgot this. But if you have a plus c in the exponent, then I'm going to show it over here, but you can just go from here to this. Is you can break up addition, if it's an exponent, to be multiplication with the same base. And then e to the c is still some unknown c. So that's just your coefficient. So what we do, we don't have to show all that. What we do is we just bring this c to the front as a coefficient. So that becomes c e to the kx. Now what is that x normally? It's t, right? If you're doing any real world problem, always keep in mind your x is time, t. So that, I think in the notes it's y equals c e to the kt. That same thing. And this is it in words. If it ever says if the rate of change of y is proportional to y, that you have to understand that is meaning this. And then you could solve it every time, or you automatically know then the original is y equals c e to the kx, and c is your initial condition, which is your initial amount of whatever y is, and k is called your proportionality constant, and you would just have to solve for that. So remember, they have to give you 2 points, and you plug in your initial condition first and get c, then you plug in your other point and get k. And we don't have an example here, so again, if you need a refresher, go back and look in your notes. Okay, so the last thing is slope fields. So what is slope fields? Is it gives you the general shape of the original, right? So it says you can kind of draw slope fields 2 different ways. You can either take the antiderivative to find the graph it should look like, or you can plug in points and just sketch slopes of that point. So I'll show you both on here, but I will say this first method, taking the antiderivative and seeing what the graph should look like, because the slope the slope field should look like original. So the shape should look like original, that's what it's saying. So it's not going to match the derivative equation, it's going to match the original. So you'd have to take the antiderivative if they give you a derivative to get the original. But now I'm going to say only do if it's a polynomial, or maybe trig like sine or cosine, that might help. If it's some rational function, I would suggest plugging in points, and also you could do a combination of both. I will show you both on here. So if we try this first thing to get the antiderivative to know what it should look like, well, what's the antiderivative of 1 over x? And you can use separation of variables if you want, because it would be dy equals 1 over x dx, and then we integrate. So when you just integrate dy, that just because if it helps you, you can think about it, it's a 1 inside there. So whose integral is just 1, that would just be y. And then y equals the integral of 1 over x is natural log of x. Ooh, why do I keep doing that? X plus c. So it has some vertical transformation. C is like a vertical transformation. So what does natural log of x look like? That's your xy graph. It has a vertical asymptote and it goes up along like that. So how would we take that and put it on here? That's kind of difficult. So let's try the other way, but we have this to make sure we're doing it right. So the second way, plugging in points, what I would do is I would make a table if you need to. And I put x. Now if this was in terms of x and y over here, because sometimes it's going to be x plus y or y over x, then I would also put y in my table, but this is only in terms of x, so I don't need y. And then I'm going to put my, what is my dy dx equal when I plug in x. So I'm only plugging in x values, so that means vertically it's going to be the same. So I'll start at -2. When I plug in -2, that's 1 over -2, so -1/2. So I'm going to draw a slope of -1/2. And again, it doesn't, we know -1 should connect these two dots, so a little less steep, maybe. And then -1 would be 1 over -1 is -1, so we want a slope of -1, so it should be a little steeper than your 1/2, but still negative direction. 0 is 1 over 0, which is undefined. So for undefined, you're going to put a vertical line. What line has an undefined slope? Vertical. That's like your asymptote, right? And then we put 1, which is a slope of 1. So it should be going positive now.